In this video, we will learn line integration in the complex plane. Complex definite integrals are called line integrals and they can be written in the form integral over c f of z dz. Here c is the given curve which is represented parametrically as z of t is equal to x of t plus I into y of t is called the path of integration, and t is increasing on the positive sense as a less than or equal to t less than or equal to b. So here I will read it again. Complex definite integrals are the line integrals. So what is complex definite integrals? They are the line integrals and they can be written in this form. So line integral is denoted by integral over c f of z dz, where z is the complex number, okay, or complex variable, and here this z is used to represent the curve, okay. Integral over c f of z dz represent line integral and c is the given curve, okay. The integral is over the curve c and c is the given curve which is represented parametrically as, so c can be represented using this equation, that is z of t is equal to x of t plus I into y of t, and this is the path of integration, okay. This c is given by z of t is equal to x of t plus I into y of t, that is the given curve. Integral is over the curve c and it is given by this equation, and we say that is the path of integration. T is increasing on the positive sense, that means t takes values between a to b. Let us continue with the problems. Evaluate integral 1 to 1 plus 2i 3z square plus 2z minus 1 dz. Solution is integral over 1 to 1 plus 2i 3z square plus 2z minus 1 dz is equal to, so we integrate in the usual way 3z square plus 2z minus 1 with respect to z. We know integral of z square is z raised to 3 by 3. Okay, first term. Second term 2z. 2z, integration of z is z square by 2. Minus 1. Integral of constant is z. So minus z. Lower limit is 1. Upper limit is 1 plus 2i. So now here 3 will be eliminated and in the second term 2 will be eliminated. So we get z cube plus z square minus z. Limit is from 1 to 1 plus 2i. So now let us substitute the upper limit. Value of z is 1 plus 2i. Upper limit is 1 plus 2i. So 1 plus 2i the whole cube. For the second term 1 plus 2i the whole square. Third term minus z value is 1 plus 2i. Then minus, we apply the lower limit. 1 cube is 1 plus 1 square is 1 minus 1. So we get this. So now 1 plus 2i the whole cube. Let us use the formula a plus b the whole cube. A cube plus 3a square b plus 3ab square plus b square. A is 1, b is 2i. So we get 1 plus 3 into 1 into 2i plus 3 into 1 into 2i square plus 2i cube, okay. 2i the whole cube, okay. Here it is cube, it's not square, b cube. So 2i the whole cube plus 1 plus 2i the whole square, a square plus 2ab plus b square. So we apply that 1 plus 2 into 1 into 2i plus 2i the whole square minus 1 plus 2i. Then coming to the next term, this plus 1 and minus 1 will be eliminated. You have 1. So we write minus 1 here, which is equal to 1 plus 6i minus 12 minus 8i. You see I square is minus 1. Okay, I square is minus 1. So we get minus here, and 2 square, we have 2 square value, that is 4. 4 3s are 12. So minus 12 we get here. Okay, here no change. 2 3s are 6i. 2 3s are 6i. But when you come to the third term, you have to square this. 2 square is 4, 4 3s are 12, so you have 12 here. I square is minus, so you get minus 12. Coming to the next term, 2 cube, 2 2s are 4, 4 2s are 8, 8. I cube means I square into I, okay. So we know I cube, so I cube value, I cube can be written as I cube is equal to I square into I square is minus 1, okay. I square is minus 1, so we get minus 1 into I, that is minus I. So now what we have to do is, we have to next, so I cube is minus 1, so in this case we have 2I cube, 2I cube, right? Here the 2I cube. So when you take 2I cube, 2 cube is 8, I cube is minus I, therefore we get minus 8I, that is this term. Then coming to the next term, 1 plus 2 2s are 4I, then squaring this, 2 square is 4, I square is minus 1, so minus 4. Here minus 1 minus 2I, or minus of 1 plus 2I minus 1. So next step is 1 plus 6I minus 12 minus 8I plus 1 plus 4I minus 4 minus 1 minus 2I minus 1. So here we can eliminate plus 1 minus 1, again you have a plus 1 minus 1, and the other terms also you can eliminate minus 8I minus 2I minus 10I, right? Similarly you have 6I plus 4I is plus 10I, so minus 10I plus 10I will be eliminated. Then the other constants are minus 12 minus 4, that is minus 16 is the integral value. So this is it, this is our solution. Okay, next question, evaluate integral over C to 1 plus I x square minus I y square dz along y is equal to x. And here let us take the question, and let z is equal to x plus iy, okay. We'll take z as x plus iy and dz as derivative of z, that is dx plus I into dy, and dz is equal to dx plus I dx. So here instead of dy, what is y along the path? So what is the path? Path is y is equal to x. So y is equal to x means what is dy? Dy is dx. So in this case dy will become dx. So we assume z as x plus iy, dz as dx plus I dy, and this dy can be replaced by dx because integration is along the curve y is equal to x, therefore dy is equal to dx, therefore dy can be replaced by dx. Now taking dx as common, 1 plus I into dx, taking dx as common, dx into 1 plus I, so dz is equal to 1 plus I into dx. So here integration is along, okay, integration is along, we integrate along, okay, we integrate along y is equal to x. So let me draw the graph of y is equal to x. Here y is equal to x will be like this, that is a straight line passing through the origin, right? So this curve is y is equal to x, this is our x-axis and this is our y-axis, and integration is from, so integration is from 0 to 1 plus I, right? Integral 0 to 1 plus I, this 0 that is real part is 0 and imaginary part is 0. What about 1 plus I? Real part is 1, imaginary part is 1. So this 1 plus I is equal to 1 comma 1 and 0 is equal to 0 comma 0. So the points will be like this. So here, okay, this straight line passing through the origin, that line is y is equal to x, and the points integral is from 0, 0 to 1, 1. So that is from this particular point. This point is 0, 0 and to the point 1, 1. So to 1, 1. So we are going to integrate from 0, 0 to 1, 1. So here you see integral 0 to 1 plus I. Okay, here 0 to 0, 1, 1, this is y is equal to x. So now integral 0 to 1 plus I, x square minus iy square dz is equal to integral. Here x varies from, you see 0, 0 to 1, 1 is the point. See 0 to 1 plus I means it is 0, 0 to 1, 1, right? 0, 0 to 1, 1. So here let us take x square, then we take x square minus I y square. What is y square? Y square, we know y is equal to x, right? The given curve is y is equal to, integration is along the path y is equal to x. So y square is x square. Since y is equal to x, y square is x square. So instead of y square we take x square. Now what about dz? Dz already we have derived, it is 1 plus I into dx. Just now we have derived dz is 1 plus I into dx. So now this equation is in terms of x. So what we are doing is we convert, since you have x and y here and integration is with respect to z, what we have to do is we have to bring all this in one variable, that is only in x we are doing. So y is equal to x, we take y as x, so y square is x square, and dz already we have derived it as 1 plus I into dx. Now this is in terms of x. We apply limit for x. What is limit for x here? Limit for x is 0. Here the x coordinate is 0, y coordinate is 0. X coordinate is 1, y coordinate is 1, right? That is 0, 0 to 1, 1. Okay, this 0, 0 to 1, 1. So now we take the x coordinate. X varies from 0 to x varies from 1. Okay, x varies from 0 to x is from 0 to 1. That is x varies from 0 to 1. So we write x is from 0 to 1. X is from 0 to 1, and then we take this 1 plus I dx, which is a constant. 1 plus I is taken outside, constant term. So integral 0 to 1 x square, taking x square as common, we get 1 minus I dx. Now here again 1 minus I is a constant term. So 1 plus I into 1 minus I, integral 0 to 1 x square dx. So now we get integral of x square is x power 3 by 3, limit is from 0 to 1. When you come to this term, 1 plus I into 1 minus I is 1 square minus I square. Okay, 1 plus I into 1 minus I. So 1 plus I into 1 minus I. So we know it is a plus b into a minus b, and the formula for a plus b into a minus b. So this is a plus b, a minus b. A plus b into a minus b is equal to a square minus b square. Here it is 1 square minus I square. That is 1 minus I square is minus 1. So we get 1 plus 1, that is 2. So here this term, okay, a square minus b square, 1 square minus I square, that is 1 square plus 1, that is 2 we get. And the integral of x square is x power 3 by 3. So applying the limit, upper limit is 1. So we get 1 by 3 minus 0 by 3, that is 1 by 3 alone. So we get 2 by 3 as the answer. Okay, so here it is 2 into 1 by 3, that is 2 by 3 is the integral value. That is solution to the question here. So